First of all, thank you for the kind introduction that you made to me. We have a very tough work today. It's the only roundtable after lunch, and before the chairman of this session will speak. So the time is very tight, the schedule is very tight, the time is running. So let's go straight. Global research ecosystem. A complex word, a complex thing. As all the presenters before, they mentioned several words that are repeating: sustainability, high production rate, collaborations. So here is representative. This table is very representative of all of these things. Collaborations. In fact, we have several tier levels. I'm from the academia, as the presenter has mentioned. So I'm coming from the knowledge. Knowledge is basic because it allows us to don't repeat all the things. So things that we know and we need to improve should be learned and should be improved by all the other actors. Also, here is Isabel. Isabel is a project manager in FIDANC, and technical coordinator of the thermoplastic department. FIDANC, all of you know, is a non-profit foundation for research, development and application of composite materials. And she is also PhD degree in the field of automatic tail layup for thermoplastic composite from my university, in fact, with our research group. Also, we have Rens Pierrick, is Business Development Manager and Senior Research Associate at Thermoplastic Composite Research Center. Also a non-profit research center focusing on processing, assembly, recycling, performance, thermoplastic of composites. He also obtained the PhD degree with distinction in the field of thermoplastic composite forming from the University of Twente. Thank you very much. David Leach, at last but not least, has more than 35 years experience in the thermoplastic polymers and composite. He has engaged in materials, process research, application, developments, operation, new products introduction, and business development. He has held leadership roles at Cytec, Henkel, and ATC Manufacturing. He's member of the Industrial Advisory Board in the American Aerospace Material Manufacturing Center. So as you see, lower TRLs, medium TRLs, and final applications. We have more or less all the collaborations possible that we need to develop that. You have seen in the morning, in the previous roundtables, a lot of good news, a lot of different developments. Here, maybe we are in the bad news, or not say bad news, just homework to be done to, at the end, achieve the final goal of achieve a final aerostructure made of full thermoplastic composite materials. So now, maybe Isabel, you are one of the chairmen today. We are very happy for that because I remember Ernesto said from you once that you have in your head all the global ecosystems, and this is the reason because I give you the first word. So the first question will be, how can this hub contribute to accelerate the industrial adoption of thermoplastic composites?
Thank you very much, Antonio. I'm honored to share the roundtable with Rens and with David. And I will take advantage of this opportunity to thank the thermoplastic team at FIRAM. I'm going to speak and I'm going to answer the questions saying we, because I'm referring to the whole thermoplastic team that is spotted in the audience, even upstairs, because they are helping with all the organization. So from our perspective, a hub is a connector in between the research centers, universities, the industry, the material suppliers, and the equipment suppliers. That's why we invited all these organizations to this event. And they are around a common goal, in this case, application of thermoplastic composite materials. And a hub can have a potential benefit because it can provide. For example, I heard from Ernova and Asituri that the investment in the equipment is quite complicated for many companies. especially when a technology is not completely developed. So a hub can offer shared equipment for these companies to develop research programs without non-individual large investment, initial large investment. At the same time, I think that a hub can contribute to the alignment. I heard from the material session that qualification and certification is a needed point, so probably it can give an added value, meaning that it helps to give trust in the value chain by establishing testing protocols. And at the same time, a hub is going to prepare to the knowledge transfer, and it's going to prepare the engineers and the technicians for the manipulation of the proper use of thermoplastic materials, because we are going to create expertise on the use of these materials. So from our point of view, there are 3 key points where a hub can contribute. So they are going to reduce the fragmentation. It's going to pull in share equipment, and at the same time, it's going to align the innovation with the industrial needs. And in our case, from FIDAM, that we are mainly working from TRL4 to TRL7, we think that the contribution could be so huge, because at these TRL levels, we are still at a really important uncertainty level in order to apply the product to the final industry. And the added value that we can generate, it's so strong, so huge.
Thank you, Isabel. So it's been very kind for you to offer many solutions, equipments, learning. Be careful of that. David, maybe you can take the hand of Isabel for some of these things and also explain how you see from your industrial side.
Certainly from industrial perspective, having been involved in, materials development originally, but more recently with a lot of part fabrication in thermoplastic composites for production applications. I think it's worth just reminding everyone where we are right now. So as we've said, a lot of the small parts, clips and brackets at TRL9, literally many millions of parts now in production and flying for a long time. That's very well established, although a lot of those are relatively simple shapes to form, and typically with fabric reinforced organo sheets, although some with UD tape. As we heard in one of the earlier sessions, we've also got kind of medium-sized assemblies, particularly using welded technology. Although again, those have been sort of point or individual product solutions, as I think Martin mentioned before. So they're not really generalized to how we develop full assemblies. And then, of course, we've got a number of large-scale demonstrators, the MFFD being one of them, that have really shown big-scale thermoplastics. But those are demonstrators. They've been done as one-offs and are typically at low TRL, maybe TRL4 or so. So what we really want to do is advance large-scale forming for structural applications with unidirectional tapes and the assembly of those as well, both to the high rate and also to larger structures. We've also heard, and certainly coming from the industrial side, I reflect this as well, it's very hard for individual companies to make large investments, as Isabel said. And so we have a little bit of a chicken and egg situation, I think, now, where there's this great potential for thermoplastics, but OEMs want to see that that technology is sufficiently mature before they will actually design it into an aircraft. But on the other hand, the supply chain is not willing to make the investment unless they definitely see that there's the business opportunity there. Not just a promise, but an actual solid opportunity. Certainly where the hub can come in and kind of add into what Isabel said is really providing that infrastructure for the equipment. And we have to consider it's not just a single process. It's everything from taking the plies, the initial material, whatever form they're in, collating that, maybe developing preforms or laminates, then taking those through the forming process and welding. And it's not just that one step affects another one. All of the steps are really integral. I think we also heard earlier in one of the presentations that even something at the raw materials end can affect how parts can be welded, so right at the other end of the chain. And so you really need to look at that in completeness. And that's certainly the big advantage of being able to co-locate all of those pieces of equipment. I'd also say the hub from the point of view of bringing together all of those parties in the supply chain. The company I've been involved with, ATC Manufacturing, we've been a member of the TPRC for many years. And aside from taking advantage of the fundamental research coming out of that and applying it to our situation, one of the big advantages is having everyone from the OEMs, tier ones, material suppliers, equipment fabricators, all in the room together when projects are defined and when we're reviewing projects. Because that way you see what all of the issues, and in addition, solutions can come from any of those parties. You know, if you have a common goal and you really understand what the issues are, then you bring a whole wider range of opinions and inputs to it. And then I'd certainly reflect the workforce development. I know, being an industry, we can never go out and hire a thermoplastics engineer. There's so few of them. We always have to bring people in and basically train them up from scratch in thermoplastics. And by the way, we found it's actually better not to take people with thermoset experience because they have a mindset of doing things one way. It's better to start with people who have actually never touched thermoplastic composites before and train them up in that.
Okay, thank you, David. Sorry for the thermoset specialist that is in the room. Rens, David has introduced some of the good points that the industry can get from the lower TRL. Can you maybe give your opinion and your view of that?
Yeah. And first of all, thank you very much for the invitation and the organization of this nice event. So I completely agree with you, Isabel, and David as well, but I will add something from the TPRC experience that we have. So at TPRC, we bring together the value chain of the aerospace industry, as David already mentioned, and together we see some common challenges faced by industry, and together we try to formulate a research roadmap based on that, and we try to solve that with pre-competitive PhD research. Going into the fundamentals and how material behaves for different processing technologies. I think key for the initiation of TPRC in 2009 was the insight from the thermoplastic community that, for solving the challenges faced by industry, you need to somehow collaborate. You need to have this joint effort. And with that, you can properly bring the challenges to the table. You can also share costs for the lab and for doing the research, as you already mentioned, Isabel. And also you can leverage investments through government funding. So you apply for funded projects with that. And with that, you are able to establish a high-tech ecosystem, and you can also train young professionals really on thermoplastic composites, and they will also find a way to industry and work in the value chain, of course. And the last thing I would like to add here is alignment of the value chain. So I guess we also heard today that some of the things that cannot be solved by each of the individual companies, but it requires alignment of the whole value chain. And that's actually, these aspects come naturally at TPRC with our joint research approach. So with that, we contribute to this industrial adoption, one with proper understanding and secondly, having this whole value chain there, I believe.
Thank you very much, Rens. In fact, even if you arise, all of you, some of the key challenge, is maybe some of the challenges. Let's ask for the key challenge to scaling the thermoplastic technologies for industrial level. And let's start for the basic of the research and development phase. That is you. So please maybe continue trying to start again with the development of that we require.
Yeah. So at TPRC, we're not really going for industrialization. As mentioned, we are pretty competitive. So really focusing on the low TRL. So mainly we're working on coupon and sub-element level, but it doesn't mean that we're not looking into industrialization, of course. So in essence, we try to improve the fundamental understanding of thermoplastic composites We try to develop accurate process simulation tools, so digitalization, of course, also mentioned today. Also best practices and guidelines, of course. And that knowledge then can be used by our partners to really develop their parts internally with their own R&D activities. I think that's the general way to go, we believe. And of course, the industrial partners that we have are the experts when it comes to industrialization, as is their daily business. So we leave that to them. And just to give some of the examples there is, for instance, induction welding, also mentioned today. So we have flying examples there with welded structures. But if you want to apply it for arbitrary geometries, you will need to have a fundamental understanding. It would be very, very good to have some accurate simulation tools there as well, really to boost this development, reducing trial and error cost. And have shorter lead times with that. There are other examples as well, for instance, stamp forming. So already for decades we're working on stamp forming simulations. So and we just continuously improving our understanding and the predictive capability of these forming simulations, and also on the structural performance side. So you really need to know what's going on with the material, for instance, again with welding. What is the microstructure that will develop, because that will in turn influence the structural performance. So you need to have a good idea about that, need to have accurate prediction simulations with that, also for certification, for instance.
Thank you very much. It's very nice that you introduced that even if you are in the very beginning of the research chains, you have to have in mind all the final developments until in the industrialization from the very beginning. So it's nothing that should be given step by step. It's a whole process that at the end should be iterated continuously. So the next step, Isabel, is yours. So it should be between the initial stage of the research and the final implementation in the industry. What is your view about that?
I have to agree with friends at the point that coupon level research is completely needed, and being in the mindset of the laboratory scale is required, because there is an economical barrier to scale up everything. So initially you have the lab in order to analyze a lot of parameters. You can check the different parameters to reach a good level of consolidation, of crystallization. But we consider that the lab can give you the information about what is possible, but you need to scale it up to understand if it's viable or not viable. And we can document a lot our experience at FIRAM by scaling up the processes, because we analyze the materials and we analyze the process from lab scale, and afterwards we try to scale them up. And we have faced with many different barriers and many different problems. So I would like to tell you about some of them. So, for example, the size effect is a really important problem when you go to scale up. So it's not the same to prepare a coupon or to prepare something for the laboratory where you can control all the boundary conditions and you can have a homogeneous environment. When you scale it up, and if you are producing something with a tooling in a real scale or near real scale, thinking about thermoplastic, that we are increasing the temperature up to 400 degrees. There are normally heterogeneous distribution of the temperature in the tooling, so we need to fight with the different degrees of consolidation in the parts. So that's a big problem for us. We have also the problem of differences in terms of cooling and heating profiles compared to the ones that we can obtain at lab scale. And it at the end have an impact in terms of thermal residual stresses, which at the end affect directly to the geometrical stability of the parts. So this is another barrier. And we normally, when we test at coupon level, we can avoid or suppress the defected areas in our panels. This is something that we normally do in order to analyze the healthy areas of our parts. But when you scale it up and you have a whole demonstrator, you need to deal with all the defects that you cannot avoid in the huge part. So at the end, I think that this is not just a question of sight, it's just a question of predictability, controllability, reliability. So at the end, what Rens mentioned about performing simulations and extracting parameters from lab scale to develop these simulations to help this scale up, I think that that's the key point and that's the question. We need the mindset of laboratory at the beginning of any work, but we need to scale it up to demonstrate that this is viable.
Mm-hmm. Let me summarize what all of you are saying is just we have mainly knowledge, but we need to develop more professionality. Develop knowledge doesn't become a real knowledge or the really established knowledge. So just for the last part is your turn, David. Go ahead for that. Finish with that.
Yeah, okay. I'll try to be quick here. So obviously builds on what Isabel and Rens have said as well. And thermal aspects are very important. Just to add another one, of course, as we mentioned, we will need to have variable thickness parts for them to be weight efficient. And if you're heating those in an oven, how do you ensure that like a thick part, a thick area of the part and a thin area of the part are having uniform heating? Another point with those blanks, of course, the material or the polymer is in the melt state. So as anybody knows, those blanks will sag. That can be managed on a small scale part, but if you're moving up to parts that might be several meters in length, what happens? This part is like sagging enormously, so you have to find a way to support it, or maybe there's another whole way to hold it, transfer it in that operation. Just on the dimensional aspect as well, another one tied into welding. If we're going to weld parts together, whatever method you're using, it's very important that you have that physical contact. So you have to have very good GD&T between the parts, because if they're not in contact, no matter whatever method you're using, they're not going to weld. In fact, a point on welding as well, I think one of the challenges is we're actually spoilt for choice. There's many methods available, and at one time I thought, okay, one of those is going to dominate, but having seen some of the work that's gone on in the last few years, I think we see different types of welding maybe is appropriate for certain parts, and we sort of maybe need to get that more generalized as well. So I think that's kind of some of the main things I would say.
Thank you. So just one last question. As I said before, time runs fast, but you are top-level speaker, and I need just to ask before the hostess give the fire away, what do you think are the key research areas that some of them you introduced that the hub as a whole should prioritize to close current technology gaps? So maybe David again.
I guess super quick. Obviously, it's fantastic if we can have all the equipment in place and everybody's working together. But I think even before that happens, there are things that can be done. As we've said, a lot of UD tape forming is more challenging than in fabrics. And I think as we're looking at variable thickness parts and more complex parts, maybe there's one, for instance, with a flanged hole or a bead stiffener. There's a lot of work that can be done, even with existing equipment, through a hub to take examples like that. I'd maybe also highlight a couple of ones that are maybe further down, but as an example, the inspection and related to that, the effects of defects. I think it was mentioned in the materials one this morning about porosity. You can get porosity in thermoplastic parts, but it's often quite different to thermosets. And I think there's a question on the effect of it with the high toughness of thermoplastic polymers. Are the levels we've got now appropriate? So I think you could do more looking at that effect of defects and also how you inspect parts and weld lines. So that's maybe super quick. That's a couple of areas.
No, yeah, thank you for keep the time. Rens, maybe it's your turn.
Yeah, can I still answer? Well, I'll briefly answer the question then. So for T/C, it's as I mentioned. So we have this consortium of industrial partners, and with that together, we define our roadmap research. And to be honest, over the past several years, this roadmap hasn't really changed too much. So initiated in 2009, thinking about a roadmap for 25 years, and it was about processing, assembly, and performance of thermoplastic composites to get them in the primary structure of an aircraft. So that's in general sense. And then in agreement with our partners, we have and are still implementing this roadmap with PSD projects. And currently we have 15 projects running in parallel, touching upon different topics, of course, all related to thermoplastic composite, but it ranges from, well, the processing, so forming, looking into wall pitch dimensional accuracy, all the way to recycling, and of course repair strategies also become an important aspect. And I believe that if you're talking about prioritization, I think a lot of different aspects need to be touched upon at the same time. So we need to look into recycling, we need to look into repair, although thermoplastic composites are not yet flying on a large scale. It's still good as a research center to look into these aspects, to have them in place once TPCs are really flying at a large scale.
Yeah, it's one of the main problems with thermoplastic is that you need to take care of all of these things simultaneously all the time. So it's like a a famous movie. So Isabel, your last time.
From our point of view, so key technologies will be the ones that take advantage of the benefits of these materials. So we mentioned that there's not a competition in between thermoplastic and thermoset. So developing proper business case with this material in order to determine which parts are going to extract a benefit from the material. But if I have to say something regarding the technologies, I will say that from the point of view of productivity, stamping, analyzing these cases that David mentioned, continuous compression molding processes. From the point of view of energy reduction, suppress the secondary cycle, so in situ consolidation, but by means of increasing the speed with the proper material developed for the process, because it also, the question is relies on the material itself and the physics of the material in the process. And I will say again that we need specific non-destructive inspection standards for thermoplastics that David mentioned, but because we are reusing the same standards that have been used for thermosets. So we need to determine and define which are the defects that appear in thermoplastics. And and from the point of view of assembly and reducing the weight of the structures, for sure, any kind of welding technology, induction, conduction, resistance welding, and the use of these technologies for reprocessing and repairing the structures. I will say that.
Thank you. A lot of questions, a lot of open questions, a lot of homeworks. But thank you to the speakers to tie to the schedule. And now I think we are nearly the last. The last is the hoster, is Ernesto. I would like to thank Ernesto and all the Tican team, and let's just finish the large and wonderful day that we have today. Thank you.